Hey class, Miss Anderson here. This is going to be a recap of Unit 2, so a test review for everything that we learned in Unit 2. We started by solving by graphing. So I just recorded this and found that these equations don't cross at a nice point, so we're going to have to change this bottom equation to be x plus 2y equals -4. So if I'm going to give you a solve by graphing problem, I'm going to make sure that they either are parallel lines, they're the same line, so no solution, many solution, or they're going to cross in a nice whole number ordered point. Otherwise, solve by graphing isn't the best method to choose. So I'm going to change that bottom equation just slightly. All right, so now to solve by graphing, I want it to be the form mx plus b, because then I can graph using m as the slope and b is the y-intercept. So if I take 2x plus y equals -5, and I'm going to start by solving this for y. So I'm going to subtract 2x from both sides, and I get y equals, now remember, this is a whole number 5 and a x term, so I can't combine these. So you either just write it as -5 minus 2x, or if you want it in the correct mx plus b, it would be -2x minus 5, so flip-flopping those. Then you can identify your slope as -2 and your y-intercept as -5. So you're going to start at the y-axis of -5. Slope of -2 is the same thing as -2/1, which means you need to do one positive direction, one negative direction. So if you go down 2, then you have to go right 1. So negative and then positive 1. So down 2, right 1. Or you can go positive 2, left 1. That's positive and then negative. So up and then left, up and then left. So rise over run. And it's negative, so when you draw it should be going downhill then. All right, then my next equation was x plus 2y equals -4. I adjusted that slightly. Solve for y, subtract x from both sides. So it's going to be 2y equals -x minus 4. Again, remember you can't combine those. One's an x, one isn't. Then divide by 2. Make sure you divide everything by 2. So we're going to end up with -x divided by 2, I need to remember that it's like having a 1 there. It's a -1x. So -1 divided by 2 is just going to stay as a fraction, -1/2 x. And then -4 divided by 2 is -2. So then your slope is -1/2 and your y-intercept is -2. So starting at -2 and then down 1 to the right 2 or up 1 to the left 2. And then I can stop graphing because I found that they intersect right here. So the solution, don't forget to write the solution then, is the point where they intersect, which is -2, -1. So that would be my answer for this question. All right, in the same lesson we learned substitution. To solve by substitution, you have to either have x equals or y equals. So if I look at both of these equations, I can see that the top equation has a y by itself already. So the top equation would be easy to solve for y. So if I take the -3x plus y equals 2, I can easily solve by y, or for y, by adding 3x to both sides. So y equals 2 plus 3x, or you could say 3x plus 2. And then I'm going to substitute that in. So now I'm going to take that y and I'm going to put it in for this y in my second equation. I cannot plug that back into the top equation because that's the equation I am using to solve for y. So it has to go into the other equation. So that's going to be 8x minus 15 times y, where y is 2 plus 3x now, equals 7. Then you will need to distribute this -15. So -15 times 2 is -30. Then -15 times 3x is -45x equals 7. Solve. These are on the same side of the equal sign. So we're going to take 8 minus 45 to combine like terms. It's going to be -37x, and we still have a -30 equals 7. It's going to work out nicely, even though it seems like weird numbers right now. We add 30 to both sides. We're going to get negative 37x equals 37. Divide by negative 37, and I get x equals negative 1. Then don't forget that you do need x and y. So once you get x equals negative 1, take that, plug it back up into here to solve for y. Y was equal to 2 plus 3 times x. So y is equal to 2 plus 3 times negative 1. Or 2 plus negative 3. So negative 1 for y. So I'd write my answer as an ordered pair. Negative 1, negative 1. Substitution. For the sake of time, I think I'm going to skip that one for the video. You could give it a try. And you can ask me if you get stuck. All right, elimination. This is where I want to be able to add the equations together. And so one of the variables needs to be opposites. This one's set up nicely. The x's line up, the y's line up, the constant line up. So now you just need to decide, do you want to eliminate the x's or the y's? I have one positive x and one negative x and one positive y and one negative y. So these are fairly equal choices. I'm going to eliminate the x's because I notice I have a negative 6x, and I know I can make the 3x into a positive 6x if I multiply it by 2. So if I take the whole top equation and multiply it by 2, I'm going to get 6x, I'm going to get 4y, and I'm going to get 12. Don't forget to do it to everything, all three terms. And then I already have a negative 6x here, so I'm not going to change the bottom equation at all. And then you add them together, so now my x's are eliminated, and I get 4y plus negative 3y is 1y. 12 plus negative 6 is 6, so I get y equals 6. Plug it back in, though. So I'm going to use the top equation, 3x plus 2y equals 6. Plugging in y equals 6 would be 3x plus 2 times 6 equals 6. So 3x plus 12 equals 6. 3x equals negative 6 minus 12 on both sides. Sorry, I skipped a step in my head. Divide by 3, x equals negative 2. Final answer would be negative 2 and 6. So elimination, you have to have opposites, either x or y variable, but the coefficients have to be opposites. And when you add them together, remember, if you add them together and everything cancels, you get 0 equals 0. That's many solutions. If all the variables cancel but the numbers don't, you get something like 0 equals 7. That's an example of no solutions. All right, next we did any linear inequalities. So a couple things to remember about linear inequalities is we had the, the dashed lines or the shading. So we shaded below the line if it was less than or equal to. And we shaded above the line for anything that was greater than or equal to. And for less than or greater than, those were the dashed lines. And then for less than or equal to or greater than or equal to, those are solid lines because the points on those lines, since they're equal to, are included in our solution set. So similar to how we solved by graphing, you are going to want your equations in mx plus b form. So take the top equation, 3x minus y less than or equal to 2, and I'm going to solve it for y. I'm going to start by subtracting 3x from both sides. I'm going to get negative y is less than or equal to either 2 minus 3x or negative 3x plus 2 if you want to keep it in slope-intercept form. And then I need y by itself, so this is like a negative 1y, so I'm going to divide by negative 1. I'm going to get y. Remember, if you divide an inequality by a negative, you do have to flip the sign. So now instead of less than, it becomes greater than or equal to, and that's specifically because you're dividing by a negative, and negative 3 divided by negative 1 is positive 3x, and then 2 divided by negative 1 is negative 2. So now my slope would be 3. My y-intercept is negative 2. I'm going to graph it with a solid line because it's greater than or equal to. The equal to tells me it's solid. And because it's greater than, I'm going to be shading above this line. So plugging in, so graphing at negative 2 to start, and then a slope of 3, or 3 over 1, would be up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, or down 3 to the left 1. It was a solid line, and then I should be shading below, so you should be shading this way, down. If it's unclear where you're shading, pick a point on the y-axis and plug it in. Like the point 0, 0 is really close to being on the line, so I'd maybe just pick the point 0, 3. If you pick the point 0, 3 and plug in 0 for x and 3 for y, you'd get 3 times 0 minus 3 is less than 2. So that would be 0 minus 3 less than 2. Is negative 3 less than or equal to 2? Negative 3 is less than or equal to 2 is true. Oh, so we should be shading above. I wrote above down here, but then I shaded below on my picture. Good thing I checked a point. Negative 3 is less than or equal to negative 2. So that point should be a solution. So I should be shading above where that point is at. So shading above that line. All right, I'm going to graph my next line in a different color. It's going to be 2x plus y is less than or equal to 1. Solve for y, subtract 2x from both sides. Y is going to be less than or equal to negative 2x plus 1. Notice I subtracted. I did not divide or multiply by a negative, so I did not flip the sign. So this one's ready to graph. My slope is negative 2. My y-intercept is 1. It's less than or equal to again, so it should be solid. And less than this time, I should be shading below it. So starting at positive 1 and slope of negative 2 over 1, so down 2, right 1, or up 2 and left 1. This was a solid line. And we're shading below. It should be this way. I have this point. We could check again. We could check the point 0, 3. The original equation was 2x plus y is less than or equal to 1. So plugging in 0 for x and 3 for 1. I would see 0 plus 3 is 3. Is that less than or equal to 1? This time I would answer no. So see how that point is on the above side of the line. So I would shade the opposite side because it's not a solution. And then the pink and the blue shading overlaps right in this area. So I would shade all of this. Then all of these points in the shaded area are solutions to the system, as well as all the points along the two lines that are here, that are boundaries to the shading, because this line is solid as well. All right. Do one more. This is a system of inequalities with 3 lines. Our first line is x minus 2 greater than 0. So this one is a special case. I'm going to solve it for x. I'm going to get x is greater than 2. This is one where your slope is undefined and there is no y-intercept because it is a horizontal or vertical line. X equals 2 is right here. This is going to be dashed because it is just greater than, so not equal to 2, just bigger than 2. And all the values of x that are bigger than 2 are going to be to the right. So we're going to make a dashed line at negative 2, and then we're going to be shading to the right for this one. For y less than or equal to 6, this one has a slope of 0 and a y-intercept of 6. So where y equals 6, right here, this one's going to be a solid line because it's equal to, and then we're going to be shading below because all the y values that are less than 6 are going to be below this line. So that's a horizontal line, and we're going to be down here. So far we have this little square right here. Our next line will, decide where we end up shading. So we got y minus 2x less than negative 1. So I do need to move the 2x over to the other side. So add it. Y is less than, it'd be a positive 2x minus 1. 2x and negative 1 can't go together. So that's how I write that. Which now I have a slope of positive 2 and a y-intercept of negative 1. So starting at negative 1 on the y-axis and a slope of 2 over 1, up 2 over 1, up 2 over 1. It's a positive slope, so going 2 positive directions, like up and right, or 2 negative directions, down and left, to make that. This is just less than, so my line should be dashed, and then it's less than, so I should be shading below that line. So I'm going to make a nice dashed line here, and below would be down in this direction. If you're unsure, just test a point again. You could pick that 0, 3 point that we picked last time. 0, 3. Plugging it in, 3 minus 2 times 0 is less than negative 1. So I plugged it into the original. That's 3 is less than negative 1, which is not true. So this red point is not a solution to the green inequality, so I would shade the opposite side, which is down here. Then all my shading intersects right in this section. So those would be my solutions. And everything along that, oops, I crossed the dashed line there just a little bit, whoops. So just be careful when you're shading, no crossing the lines. And then any of the points on the dashed lines would not be solutions as well. All right, word problems. So you have $70,000 to invest. You want to invest in money market, stocks, bonds, you want to invest in stocks, bonds, and money market funds, yielding 11%, 7%, 9% respectively. If you want to invest the same amount of money in money market as in bonds and stocks combined, your goal is to make $66,400. How much should you invest in each fund? All right, so variables first. We got X could be stocks, Y could be bonds, and Z is going to be our money market. Stocks is 11% yield, bonds is 7% yield, and money market is 9%. If you have the total amount of money, X plus Y plus Z, you had $70,000 to invest. So that's your first equation. And then each percent that you invest, so if you get 11% of stock X plus 7%, so 0.07 stock Y, plus 9%, 0.09 of Z, if you earn 11% on X, 7% on Y, and 9% on Z, you want that total earnings to add up to $6,400. That's your goal to making that investment. And then you want to invest the same amount in money market as in stocks and bonds combined. So you want your money market account Z to equal your stocks and bonds combined, Y plus X. So then it's an equation of 3 variables with 3 unknowns. So you're going to set up your augmented matrix. You will have to subtract X and subtract Y in your last equation so that you have negative X minus Y plus Z equals 0 so that it lines up the same. So then your augmented matrix, your first row will be 1, 1, 1, and 70,000. And then 0.11, 0.07, 0.09, and 6,400. And then -1, -1, 1, and 0 for your last row. Put that into your matrix. So matrix, go over to edit. I always edit A, it's 3 by 4. So 1, 1, 1, and 70,000. Be careful not to make a mistake here. 11, remember 7% is 0.07, 9% is 0.09, and then you want to make 6,400, and then -1, -1, 1. Make sure X, Y, and Z are lined up in the correct positions on that last equation, and you get everything over to the other side. Go back to exit. And then we're going to go to matrix math, run RREF from our home screen. I don't know why it doesn't show up the first time I run it sometimes. There we go, and I'm going to choose matrix A. And running that tells me that I'm going to put in 20,000 into stocks and 15,000 into bonds and 35,000 into money market. So you could write me a nice sentence or at least label those nicely. That'd be great. I'm just being a little lazy for time here. Okay, then matrix operations. So scalar multiplication is just similar to distributive property. You multiply the constant in. So 2 times everything in here would give me -6, 22, 4, and -4. So scalar multiplication. Matrix multiplication, you would multiply rows by columns. And you just have to make sure that they match up. So 2 by 2 and then 2 by 3. You are able to do this in your calculator if you'd like. You could type in matrix, go over to edit, do matrix B is your 2 by 2, put in your values, -2, 4, 3, and -1. And then go back to matrix and edit matrix C to be your 2 by 3 matrix and put in those numbers, 5, 2, 3, 0, and 1. Go back to your home screen and then do matrix. So I called this one B and this one C. So from the home screen, I would do second matrix B times second matrix C and enter. And it would be 16, -10, 0, -9, 15, and 5. Now, on the test, I'm going to ask you to show me the longhand work for like row 1, column 2, for example. And so you're going to do, okay, well, row 1, column 2, I should get -10. So I get that by taking -2 times 5, and I add that to 4 times 0. And so I get -10 plus 0, which is -10. So I want you to give me the answer, and you can do that all by hand, or you use your time wisely. You can use your calculator, and then putting row 1, column 2, and then showing me the work for it. For adding and subtracting, remember the dimensions have to be the same. So for this one, it would not be possible because you can't add a 2 by 2 and a 2 by 3. For this one, I'm going to change this to a plus a -4 times this. And then I'm going to distribute the -4 in there. So I'm going to multiply and then I'm going to add. So I'm going to keep my first matrix C the same. They're both 2 by 3, so I can do it. Then I'm going to add. I'm going to distribute the -4 inside. So I'm going to multiply everything in there by -4, -16, +8, -20. And then, so follow the order of operations, add, and then, or multiply, then add. Then adding, you add corresponding spots. So -1 plus -4 is -5. 10 plus -16 is -6. 3 plus 12 is 15. 9 plus -16 is -8. No, it's late. -7. 7 plus 8 is 15, and -1 plus -20 is -21, and that would be your answer. All right, solving in matrix equation for x and y. So just remember you have your equal sign, so the matrices are equal, which means the corresponding positions have to be equal. So do any matrix operations that you need to, like this one, I have a 3 times this matrix, so I'm going to multiply that in. I'm going to get 6x and then -3, 24, and then 15y. Once you've done all your operations on the left side, then you have an equal matrices. So that means that your 6x has to be equal to the 3 spot. And if 6x equals 3, then that means if you divide by 6, x will equal 3/6, or reduced, x equals 1/2. And then the y is down here in this spot, so that means that 15y has to equal -60, so dividing by 15, and y has to equal -4. So you get your x is 1/2 and y is -4 for your answers for that one. So solve the left side and get it down to simplified as much as you can, and then it should be, the matrices should be equal. So then the corresponding positions are equal, and use that to figure out what the variable has to be. Notice that the other two spots are equal as well. And last but not least was augmented matrices. So this is the one where you just need to make sure to translate it into an augmented matrix of coefficients. So your first row would be 1, 2, -1, -1. And then you would have 4 for x, -2 for y, no z's, and then -16. And then here I have no x's, no y's, a 3 for z, and a 6. Plug that into your matrix A and run the RREF. And the answer should be, I should have did this ahead of time, sorry. 1, 2, -1, -1. 4, -2, 0, -16. Okay, go back to exit, run RREF of A. And I get the ordered triplet, -3, 2, 2. Final answer. All right. That's it. That's unit 2 in a nutshell. Good luck studying. Let me know if you have questions.